Okay, this is the free response from your final exam, so I'm going to start it from the beginning. This is the information that we were given, and I just want to point out that I marked it with pi and 2 pi because I didn't want to forget and say from 3 to 6, so that's why I did that. Okay, so for part A, it says find g of 1. So I'm going to put it right under what g is, and that means wherever there's an x, I'm going to put a 1. Okay, so if the limits are the same, that means there's no space there, and therefore the integral would just end up being equal 0. So g of 1 was 0. Then you need to find g prime of 1. Okay, before you can do g prime of 1, you have to do g prime. So I'm going to erase all this. Whoop. Okay, so we're going to look for g prime. So if I add a prime on the left side, I have to add a prime on the right side. And now that's the second fundamental theorem of calculus, which says to just take this upper limit and put it in wherever there's a t. So we're just going to get f of x times the derivative of the upper limit, but the derivative is just 1. So g prime equals f of x, and we want g prime of 1, so you're going to put a 1 where there's an x, so you want f of 1. Well, this is the graph of f, and here's where x is equal to 1, and the y value is 0. So that completes part A. Okay, I'm going to erase this. Okay, and I'm going to rewrite now what we just found, because we're going to need that again later, which is that g prime of x equals f. Okay. All right, part B. When is g increasing? So just in general terms, g is increasing when g prime is positive. But we know that g prime equals f. So the real question is, when is f positive? So you're going to look at this graph of f, and when is it positive? That means above the axes, and it's from here to here. So that goes from 1 to pi. So that was the answer for part B. Okay, part C is asking for an absolute min. Okay, so an absolute min occurs at the endpoints, which would be g of 0, or g of 2 pi, or at the critical points. So where are the critical points? So we get critical points by taking the derivative of g and setting it equal to 0. But we know that g prime is equal to f of x. So when is f of x equal to 0? So when is it hitting the x-axis? Well, right here at 0, but we already have that right here. At 1, so we have to test g of 1. Right here at pi, so we have to test g of pi. And right here at 2 pi, and we already have that over there. Okay? Alright, so the first thing we're going to find is g of 0. Okay, so this is g. This got erased by accident. Okay, that's our function for g, and we want g of 0. So that's the integral going from 1 to 0. But you're not allowed to have the smaller number on top, so we're going to flip it and make a negative. Okay, so g of 0 is going to be negative, and now we need to know what is the area from 0 to 1. So from 0 to 1, we don't know the exact area, but we do know it's a small negative number, right? So it's a negative number. Now a negative negative is going to give us positive, and therefore g of 0 is going to be some positive number, and I'm just going to put s in parentheses to say small, because it's just this small little piece over here, in case that's important to us later. Okay? Now we'll do the next one. Okay, next is g of 2 pi. So that's going to be the integral going from 1 to 2 pi. Okay, so from 1 to 2 pi, that's from here to here. Again, we have no numbers, but you can see this is a positive value, and this area is going to be a negative value, and you can clearly see from the picture that this section over here is bigger than the other section, so therefore it's going to be more negative, so therefore it's a negative space. So we know that g of 2 pi is going to be negative. Okay? That's all we know right now. Okay, let's just keep going. Even though this looks not hopeful at all, you'll see it will be very hopeful. All right, g of 1 we already did in part A, and that was 0. And then we just need g of pi. Okay, so we're looking for the area going from 1 to pi. That's this piece over here. That is all positive. Okay, so let's look at our different y values here. Okay, so this one is positive. That's positive. And we're looking for the absolute min. So definitely that's out. Here's another positive, so that's out. And so now you have to choose between a negative number or 0, which is going to be the smaller number. It's going to have to be the negative. So therefore, the min occurs at 2 pi. So how would we write this all up? Let's just erase this and make some room. So the question says, find the value of x at which g has an absolute min. So you're going to write at x equals 2 pi, there is an absolute min. And all the work that you have over here, that just proves that, like, it's asking for you to justify, that justifies it. Because it's showing that only at 2 pi would you get a negative number. Okay, that's part C, and now let's go to D. There's a bunch of room. Now, just so you know, for part D, I marked a lot of you wrong, and then I realized it's just asking for one solution. There's actually 4. Okay, so in the integral from 0 to 2 pi, is g ever tangent to the x-axis? So the x-axis is this. So if you're going to be tangent to the x-axis, then that would mean that you have a slope of 0, right? Because this is a horizontal line. So you want to know, when is g prime equal to 0? Well, we already found that g prime is equal to f of x. So the question is, when is f of x equal to 0? So you're going to look at your graph of f, which is right here, and it's in these 4 places. So at x equals 0, 1, pi, and 2 pi, then f of x equals 0. So any of those answers would have been correct, but the question said, is there a value? And so the answer is yes. Yes. This does not want to work. Okay, so yes, there is a value of x where, let me just make some room up here, I'll finish it up here, where g is tangent to the x-axis, and then you could put in parentheses slope equals 0, and then you could write something like, for example, when x equals 1. Okay, just something like that. But as long as you have something like this, then that would be why. They really just want to know that you know that you're looking for a slope of 0 and that g prime is equal to f. And that's that.